Have you ever come across a problem so big it just feels like no single person could ever solve it?
Yeah, definitely. I think we all have.
Well, that's kind of the thought process behind what we're going to be looking at today, multi-agent AI systems.
Oh, cool.
Instead of just like one super powerful AI trying to do absolutely everything, imagine if you had a whole bunch of, specialized AI, you could say brains, working together.
Like a team of AI.
Yeah, exactly.
That's a really cool way to put it.
Yeah.
And for this deep dive, we've actually managed to get some pretty good resources.
Oh, awesome.
Yeah, we've got some hands-on insights from blog posts, some from Microsoft, some from Medium, and then we also have a pretty good overview from Wikipedia.
So we're going to be able to go pretty deep.
Yeah.
So I guess the mission today is really to just cut through all that tech jargon and all the hype and really get to like the core of what these multi-agent systems are.
For sure.
Why they're so powerful, where are we actually seeing them used in the real world?
Like real-world applications.
Yeah. And I think there are going to be a lot of like aha moments along the way. This is such a like dynamic and interesting area of AI.
Definitely.
So why don't we start with just the very basics?
Yeah.
What exactly is a multi-agent system, or as they call them, an MAS?
Right. So basically it's where you have multiple independent things, like, things, entities.
Yeah.
We call them agents.
Okay.
But yeah, working together to try and achieve some sort of complex goal.
So kind of like AI, but built in with teamwork.
Yeah, exactly. Like AI teamwork.
I like that.
And when we say agent, we're not just talking about code.
Right.
It can be like software, robots, even humans.
Oh, wow.
Or, even teams of humans.
Yeah.
All working with some degree of autonomy.
Yeah.
And each agent can like sense what's going on around it and, learn from experiences, make decisions, and then act.
That's so cool. And it's really different than what we've talked about before, which is like a single agent system.
Right.
Where you just have one large language model or one tool trying to do every single step.
Yeah. Yeah.
Which is fine if the task is pretty simple.
Right.
But when you start getting into more like complicated workflows that need a lot of different expertise, then it starts to not work so well.
It doesn't work so well.
It's like you're running a restaurant. And one person has to be the chef, the waiter, the cleaner, the accountant, all at the same time.
Right.
Doesn't really work.
It's not going to work.
It's much better to have a whole team where they can communicate, divide up the work.
Yeah, specialize.
That's really the kind of, driving force behind multi-agent systems. Agents collaborating, sharing tasks so they can be a lot more efficient.
Yeah, efficiency through collaboration.
And the really cool thing is like there are so many advantages to having this collaborative structure.
Right.
I think one of the first things that jumps out is just how flexible and scalable it is.
Right.
Can you maybe expand on that a little bit? How does that work?
Sure, yeah. So because this system isn't like reliant on a single point of control, like everything going through one thing, it can very easily add or remove or adjust agents as needed.
Right.
So if a problem becomes more complicated, you just bring in more agents.
Yeah, that makes sense.
With the specific skills that you need to solve that problem.
So much more dynamic than just a single agent, right?
Yeah, yeah. And it also makes it a lot more robust and reliable.
Right, because if one agent goes down, it's not like the whole system crashes.
Yeah, exactly. Because the control is so distributed, the other agents can step in and handle it.
Yeah, yeah.
Or figure out a new way to achieve the objective.
It's like built-in resilience.
Built-in resilience, exactly.
And this is where it gets really interesting, this whole idea of self-organization and coordination.
Right.
It's like they can figure stuff out on their own.
Yeah. So without explicit instructions, like you don't have to tell them everything to do.
Right.
The agents can actually develop what we call emergent behavior.
Yeah.
Which means they can learn how to divide up tasks, make coordinated decisions, even resolve conflicts amongst themselves.
That is so cool.
Based on the rules of the system.
It reminds me of like a swarm of bees, how they can just decide as a group where to build the next hive.
Yeah, it's a great analogy.
Amazing.
And then we have real-time operation.
Right, yeah.
So because you don't need human intervention, in environments where things are changing really fast, the agents can react almost immediately.
Like super fast.
Yeah. So you think of like autonomous vehicles avoiding an accident or smart traffic lights optimizing flow in a city.
Yeah.
They can all adjust on the fly.
Wow, that's so cool. So instead of having to wait for like a central command center to process everything and send out instructions, the agents on the ground can just do it themselves.
Exactly, yeah. It's a really powerful concept.
So powerful. And another benefit we saw was specialization.
Right. So instead of one AI trying to do everything, You can have agents that are specifically really good at just one thing.
Right.
So like you might have one agent that's great at summarizing documents.
Yeah, yeah.
And then another one that's great at translation.
Right.
Or maybe another one that's really good at generating creative content.
So each one has their own specific strength.
Yeah.
Which honestly is a lot like how a good team of humans would work.
Exactly, yeah. You don't want just one person who's like okay at everything. You want a bunch of people that are really good at their one thing.
Exactly, yeah. And it sounds like you can even kind of customize your own team of agents for what you need.
Yeah, exactly. So based on the challenge, you kind of mix and match the different agents.
Wow.
So you have the perfect team for the problem you're trying to solve.
And because they're all individual, you can update one without having to redo the whole thing.
Exactly, yeah.
Right. Like if one's not working that well, you can just make it better without having to redo the whole system.
Exactly, which makes iterating and improving so much faster.
Yeah, that's a good point. And what about this black box problem? You know, the idea that we're always hearing about with advanced AI, where it's so hard to understand why an AI made a certain decision.
Yeah.
Is it any better with multi-agent systems?
In a lot of cases, it is.
Oh, wow, okay.
Because you have these distinct agents and they each have their roles, it's a lot easier to kind of trace how each one contributed to the overall behavior of the system.
Yeah.
You can see who did what and why.
Oh, that's interesting. Okay, so we've kind of covered like the what and the why. Now let's get into the how.
Okay.
How do these systems actually work like on a technical level?
All right. So there's a few key components.
Okay.
First, you got the agents themselves,
Right.
each with their own abilities. Then you have the environment where they operate.
Yeah.
Could be a simulated world or like the real world.
Okay.
And then, really important, you have the interactions between the agents.
Okay.
This often happens through standardized communication protocols or languages.
So they have a way to talk to each other.
Yeah, they have to communicate. Okay. And then lastly, you have the organization structure, which can be hierarchical, some agents in charge, or it could be more decentralized where the organization kind of just emerges from how they interact.
Interesting.
Yeah.
And each agent has its own set of like abilities or skills.
Yeah,
right?
definitely.
Yeah.
So they need to be able to learn, plan, reason, make decisions.
All the good stuff.
All the good stuff, yeah.
And those interactions you mentioned, like cooperation, coordination, and even negotiation, those seem really important for the system to work together as a whole.
Right. They need to work together, so they need to cooperate on shared goals, coordinate their actions, and, yeah, sometimes even negotiate if goals are conflicting.
It really is like a team.
It is, yeah.
So you mentioned earlier Marco Casalina's work at Microsoft.
Right, yeah.
He created a really cool example of a multi-agent system using semantic kernel.
Yeah.
Can we go into a little more detail about that?
Yeah, for sure. So Marco built this questionnaire answering system, and it uses semantic kernel, which is a framework that Microsoft made for building these intelligent applications.
Oh, cool.
And this wasn't just a theoretical project or anything. He actually built it to automate a real task.
Oh, wow. So practical.
Yeah, so in his work, he has to answer lots of these questionnaires, like from RFPs.
Right, yeah.
And he built this system to automate that.
Oh, that's cool.
And he had 4 distinct agents in the system.
Okay, so 4.
Yeah, so first there's the question answerer, answers the question.
Makes sense.
Then you have the answer checker.
So make sure the answer's right.
Yeah, exactly. Then there's a link checker, because sometimes you include links in answers, as sources.
Right.
And make sure those are valid, they're not broken or anything.
Right.
And then lastly, you have the manager.
Okay.
Who oversees everything, makes sure all the checks are done, and then it decides on the final answer.
So the manager is really running the show.
The manager's in charge.
Yeah.
Yeah, and the question answerer and the answer checker actually got their info from public data.
Interesting.
Yeah, using Bing web search.
So it's grounded in like real world data.
Exactly.
And then you mentioned this thing called agent debate, which sounds pretty fascinating. Can you explain what that is?
Yeah, so sometimes the agents would disagree.
Oh, okay.
Like on how to answer something or if a piece of information was right.
So they're not always on the same page?
Not always. So when that happens, the manager agent would step in.
Okay.
And start this rewrite cycle. So it would force the agents to reconsider their positions.
Like they have to go back and forth?
Yeah. And they'd have to do this until they agreed.
Wow. So it's like built-in critical evaluation.
Exactly.
So you're making sure that the answers are more robust and reliable.
Yeah. And to make sure it doesn't go on forever, he set a limit of 25 interactions.
Okay.
But he said that it almost never went that far.
Interesting. And he could use different AI models for each agent too, right?
Right. So he could choose which AI to use for each job.
Like you could have like a really powerful one and then a less powerful one if it doesn't need to be as complex.
Yeah, exactly. So he started by using GPT-4o for all 4 agents.
Right.
But he said, for something like the link checker, where you don't really need the most powerful AI,
Right.
you could use a smaller model, something like Phi-3,
Yeah.
which would also save some money.
Right. It's more cost effective.
And then he said something really interesting, which is that having different models could actually be a good thing
Oh, okay. How so?
because they bring different perspectives to the debate.
Oh, interesting.
So the answers could actually be even more comprehensive.
I like that. That's a really cool way to think about it.
Yeah.
And it wasn't just public data they could use, right?
Right, so he said that you could also ground these agents in an organization's own private data.
So if you have your own data, you could use that.
Yeah,
That's
exactly.
really flexible. And it sounds like he really liked using semantic kernel,
Yeah, he seemed pretty happy with it.
especially compared to other frameworks.
Right. So he said it was, really elegant, not a lot of code to get it up and running.
Yeah, that's awesome. Especially if you're trying to build something quickly.
Exactly. Although he did say that the documentation was a bit limited at the time,
Ah,
but still, he was able to get a lot done in a short amount of time.
so it sounds really promising.
Yeah, for sure.
So we've looked at a really good example of how these systems work and how they can be used. Now let's kind of zoom out a little bit
Okay.
and talk about some of the wider applications and real-world examples of these systems that are popping up everywhere.
Yeah, it seems like almost every industry could benefit from this.
So where are we seeing them?
So one big area is smart power grids,
Oh, interesting.
which need to coordinate all these different sources of energy.
Yeah, and especially renewables.
Exactly, renewables.
Yeah, so it has to figure out how to balance all the different sources.
Right, because you have solar, wind, which are intermittent,
Right.
and then you have the fluctuating demand from consumers.
Yeah,
So it's super complex, and they're using multi-agent systems to try and manage all that.
that's so cool.
Another really promising area is disaster rescue,
Yeah,
where you could have like a team of robots
yeah.
going out to like a disaster area, mapping the area, finding survivors, delivering supplies, all autonomously.
Oh, wow, that's amazing.
And then we have manufacturing systems,
Right.
which is using intelligent agents to control the machines, optimize inventory, streamline logistics.
Yeah, so it can really speed up production.
Yeah, make things more efficient.
And what about transportation?
Oh, that's a big one. So you have like optimizing taxis
Right.
or adjusting traffic lights in real time.
Yeah, so easing congestion, things like that.
And then the really exciting thing is coordinating autonomous vehicles.
Yeah, like fleets of self-driving cars.
Yeah, and a really cool example of this is Waymo's CarCraft.
Oh, yeah, I've heard of that.
It's basically a simulation environment where they create these virtual worlds
Yeah.
with like AI drivers and pedestrians.
So it's simulating the real world?
Yeah, to test their self-driving algorithms.
So they can see how the cars would behave in real-world situations.
Yeah,
That's so smart.
it's super complex, very sophisticated, multi-agent system.
What other areas are we seeing it in?
So another area is supply chain,
Okay.
which can benefit from AI agents handling things like demand forecasting,
Mm-hmm.
inventory planning, or managing these like complex bidding processes between suppliers.
Right, so it could really save companies a lot of money.
Yeah. And then we also have healthcare,
Okay.
which could use multi-agent systems to coordinate patient care,
Yeah.
optimize hospital resources,
Right.
even contribute to precision medicine by analyzing patient data.
Wow. And then there's so many other things that we read about in the Wikipedia article,
Right.
like online trading, target surveillance, even modeling social structures and behaviors. It's like it can be used for anything.
Pretty much.
And one thing I thought was really cool was how organizations like the Center for Modeling Social Systems are using them to create simulations of societies,
Right.
to study things like climate change, energy policies, spread of diseases, even conflict management.
It's like they're creating a virtual lab to study the real world.
That's amazing.
Now, we can't forget about entertainment like computer games
Yeah,
and even films.
right. Yeah.
They're using agent-based systems to make the characters more realistic.
It's everywhere. So for someone who might be thinking about building or implementing a multi-agent system, what are some of the things they should think about?
Yeah, so the first thing is to clearly define what the system needs to do.
So have a plan, a roadmap.
Yeah, what problems you're trying to solve, what each agent will do, how they'll interact.
Makes sense.
And then, because these systems can be pretty complex, you need to think about the computational resources you'll need.
So like how much computing power it's going to take.
Yeah, the processing power, the memory, the communication bandwidth,
Right.
it can get pretty demanding.
And before you actually use one of these systems in the real world, testing is critical, right?
Right, so lots of simulation testing
Yeah.
to make sure everything works as expected, to catch any problems early on.
Right, so you don't get any unexpected results.
Yeah. And security and safety are huge.
Of course.
Yeah, you got to protect the communication between agents, prevent anyone from hacking in,
Right.
and have fail-safe mechanisms built in so nothing goes wrong.
Yeah, that's super important. So when you're actually designing the architecture of the system, does it matter what approach you take?
Yeah. You want to pick an architecture that's best for the specific problem you're trying to solve.
Yeah, okay.
And the general advice is to start small.
Okay.
Start with a simple system and then gradually scale it up.
Makes sense. It's kind of like how we always recommend, starting with a small language model and then working your way up.
Yeah, exactly.
You don't need to go all in right away.
Not right away.
What are some other best practices?
So it's really important to define clear roles and responsibilities for each agent.
Right, so everyone knows what they're supposed to be doing.
Yeah. And you also want the communication protocols between the agents to be flexible, because things change.
Mm-hmm.
You also need to find the right balance between autonomy for the agents and control for the system as a whole.
Yeah, you don't want them to go rogue.
Exactly. And monitoring is super important.
So keeping an eye on how everything's working.
Exactly. Tracking performance, finding areas to optimize, and addressing any safety concerns.
So it definitely sounds complex, but incredibly powerful.
Yeah.
And it seems like these multi-agent systems are starting to work with all these other modern AI technologies.
Right.
So
Yeah.
how are they integrating with those?
Yeah, so we're seeing this awesome integration with large language models, LLMs.
Right, like GPT-4?
GPT-4, exactly, which makes the agents better at understanding language, generating it, and reasoning.
Yeah.
We're also seeing them use reinforcement learning.
Oh, wow. So they're getting smarter over time.
Yeah, they're learning from their experiences, figuring out the best ways to make decisions.
That's so cool.
And neural networks are helping with things like perception and pattern recognition.
So they can see and understand the world around them.
Exactly. And even blockchain is being used
Oh, wow.
to make the interactions between agents more secure and transparent.
And edge computing is also playing a role, right?
Yes, definitely. So that helps with response times, especially for systems that are spread out geographically.
So it's like all of these different AI advancements are coming together to make multi-agent systems even more powerful.
It really is. And it's evolving so fast.
Yeah, especially in 2024.
Yeah, this year's been crazy.
So what are some of the most recent advances and frameworks that have popped up?
So we're seeing a lot of progress in distributed consensus control,
Okay.
which is how groups of agents agree on stuff without a central authority.
That's cool.
And formation control, which is important for robots and vehicles that need to move together in a coordinated way.
Right, so they're not bumping into each other.
Exactly. And then, inspired by nature, we have research into flocking and swarming behaviors,
Oh, I love that.
which is how large groups of agents can coordinate so effectively.
Like a flock of birds or a school of fish.
Exactly.
Yeah.
And then, of course, there's security research,
Of course.
because with these systems getting more and more sophisticated, they need to be protected from all kinds of attacks.
Yeah. And what about the frameworks and tools for building these systems?
Right. So there's some really cool ones.
What are those?
OpenAI has this experimental framework called Swarm.
Oh, okay.
And it's designed to be lightweight and modular so you can easily build these collaborative agent systems.
Cool.
And then there's AutoGen from Microsoft,
Okay.
which has become really popular for building applications that use multiple conversational agents.
So agents that can actually talk to each other?
Yeah, it's open source. It's really powerful.
That's awesome. What about MetaGPT? I read about that one.
Oh, yeah, that one's cool. So it basically simulates a whole software development team.
What? Really?
Yeah, with specialized AI agents.
So you could have an AI product manager, an AI...
Exactly, each with their own specialized LLM.
That's so cool.
And then there's Relevance AI,
Okay.
who came out with a no-code multi-agent system framework.
So you don't even need to know how to code.
Well, that's the idea.
That's so cool.
Yeah, so anyone can build these systems.
So it sounds like we're making a lot of progress, but there must still be challenges.
Yeah, for sure.
What are those?
Well, one of the biggest is scalability.
Okay.
So as these systems get bigger with more agents, it gets harder to manage all those interactions.
Right. It just gets more and more complex.
Exactly. Another one is interoperability.
Okay.
So making sure agents that are on different platforms or using different protocols can still talk to each other.
Yeah, they need to speak the same language.
Yeah. And then there's the human-agent interaction.
Right. We need to be able to understand and control these systems.
Yeah, so creating natural and intuitive interfaces for that is really important.
So it's all very exciting, but we're not quite there yet.
Yeah, more work to do.
So where do you see this field going?
Well, I think we're going to see individual agents get even smarter.
Yeah.
They're going to be able to reason better, plan better, and handle more complex problems.
Awesome.
And multimodal interaction is going to be huge.
Oh, interesting.
So instead of just text, they'll be able to understand and use images, sounds, all kinds of data.
Like a more human experience.
Exactly. And then we'll see more automated orchestration of the agents.
Okay.
So the system can automatically manage how they work together.
That's cool.
And then security models are going to have to get better.
Yeah, of course.
And we'll probably see more ideas from swarm intelligence being used.
Oh, that's always cool.
Taking inspiration from nature to make these systems even more optimized.
So it really feels like we're at this turning point where multi-agent systems are moving from research to real-world applications.
Yeah, they're becoming practical.
I'm really excited to see what happens in the next few years.
Me too.
So for you listening, multi-agent systems offer a really powerful and flexible way to solve complex problems.
Right, and they're inspired by nature.
Yeah, by how real-world systems work. And this is a field that's moving really fast.
Yeah, beyond theory into real-world solutions.
Exactly. So here's a final thought. Think about the core principles of how these systems work. Specialization, communication, coordination.
Yeah, like a good team.
And how could you maybe apply these principles to challenges in your own life or your work,
Right.
even if it's not directly related to AI? What could you do differently if you start thinking in terms of intelligent teams?
That's a great point.
We encourage you to check out the resources we mentioned and keep learning about this amazing and rapidly evolving field of multi-agent AI. Thanks for joining us for this deep dive.
Thanks for listening.
We'll see you next time.
See you later.